let's look at 1.14 first. Okay, this is going to be 1.14, and 1.15 is the last of the geometry concept. This is the addition line segment postulate. The M's is nothing more than the labels, okay? Some of them, it gets a little confusing because some of them have labels, like number 2, and some don't. You have to be careful not to use those labels when you're adding these. Okay, the thing we do here is we're adding up the little lines plus the bigger lines. Or, I'm sorry, adding up the 2 little lines to get to 1 big line. It's a very easy concept. Again, we're just adding 2 little line segments to get the big one. So here I'm adding 3 meters plus 5 meters to get 8 meters. That's my answer. Now, obviously, they're going to get a little more difficult. Burgess, put the phone away. Okay, number 3. I'm going to add 3x plus x. This time they tell us the length of the larger line segment is 20 inches. Now I have to solve for x. Okay, 3x plus x is 4x equal 20. Then I'm going to divide each side by 4. So x equal 5. Then I have to plug it back in because they want to know what the small line segment MN is. Well, we know it's 3x. We know x is 5. So 3 times 5 is 15. And the O is x. We know x is 5. So we plug it in and get 5. Give me a couple minutes. Number 5. When you hear the word midpoint, what do you think of? In the middle. So if this B is in the middle, what do I know about these 2 line segments? They're exactly the same. They're equal, right? So my equation is going to be 6x minus 12 equals 36. Then I just solve for x. Okay, add 12 to both sides. I get 6x equals 48. Divide both sides by 6. So therefore, x is going to be 8. Okay, AB, quiet. Craig, put the phone away. Quite a few. AB is 6x minus 12. I know x is 8, so I have 6 times 8 minus 12. 6 times 8 is 48, minus 12 is 36. If AB is 36, we know that BC is 36. We could have just stated that it was 36 because they're equal to each other. I'm not sure where you're going with that. All right, they want to know the entire length of AC from A to C. From A to C. Yes. If A to B is 36 and B to C is 36, what's A to C? Yep. Either way. Yep. Let's do number 9. Let's do 7 first. Okay, number 7. P is the midpoint. So what do I know about these two? If P is the midpoint, they're equal. So my equation, 73 equals 6x plus 1. I'm going to subtract 1. So I get 72 equals 6x. Then I'm going to divide both sides by 6. So x is going to equal 12. PV, P to V, I don't even have to solve this. What's the difference between P to V? If P is the midpoint, A to P is 73, what does P to V have to be? 73. What's AV? Yeah, 73 plus 73 or 2 times 73, either way, 146. All right, number 9. Here. Is it hers? Number 9. See, we don't have a midpoint, but we do have the length of the entire line segment, and that is 150. So what's my equation? Well, don't forget about this little one. Solve for x. Let's see, combine like terms. 9x.
I just did that. Okay.
Okay, what WZ is 8x minus 12. Our x is 18. 8 times 18, 144. And 144 minus 12 is 32, right? They're all for points. Now, whether the points count for your overall grade is a different story. Not on this sheet. Okay, so let's look at 1.15. Those are the summatives. All right, here you have some more midpoints So we did those. Yes, David. Oh, they're on the back table. You pick them up. I'm sorry. I forgot to tell you, pick them up when you come in. Yes. All right, there's a couple of new things in this section. We have what's called angle bisectors and vertical angles. Okay, just like midpoint, what do you think of when you hear the word bisect? Bisector. Right in half, right? Bisects it. Okay. So if I have an angle measurement, what it does, it's the same thing as like a line segment. It takes one big angle, splits it in half. Takes one big angle, splits it in half. So we're going to do a couple of examples. Again, we're going to either set them equal to each other, or we're going to add them and set it equal to the big angle. Now, KM here is our angle bisector. Number 9. KM is our angle bisector. So it splits this big angle into equal parts. Now we know they give us some other information. Angle JKL, this angle, the big angle here, is how much? It says 110. Okay. So you could do this a couple of different ways. We know that this measurement is 4x plus 5 because it's the same, it splits it in half. Or we could just take one of these, the 4x plus 5, and we could set it equal to half of 110, which is 55. That's probably the easiest way to do it. Okay. Then we solve for x. I'm going to subtract 5. I get 4x equals 50. Divide by 4. 50 divided by 4 is going to be a decimal. What is it? Thank you. Angle JKM. So they want JKM. We already know it's 4x plus 5. We know x is 12.5. 4 times 12.5. Again, it better be 55. Is it? Let's do another one. Let's do number 13. Okay, I know this is an angle bisector because of this little symbol here. So I know that these two angles are what? Equal. So I'm going to set them equal to each other. 6n minus 10 equals 4n plus 8. Put the phone away. I don't care. Put it away. Okay, solve for n. If you don't put the phone away, I am going to write your referral and send you to ISS. You got about 30 seconds to put it away. Okay, solve for n. Subtract 4n from both sides. Add 10 to both sides. And divide both sides by
2.
So n equals 9. Angle NPR. No, let's do this one. NPM. NPM is 6n minus 10. Not angle bisector. Okay, n is 6. 6 times 9 minus 10. 54 minus 10. 44. NPR. It better be 44. 4 times n, 36 plus 8, 44. 44 plus 44 is going to be, for the big angle, NPR. Any questions on angle bisector?
I already know.
So we did line segments, angle bisector. The last thing we're going to do for geometry concepts is vertical angles. Vertical angles are made by two intersecting lines, creating vertical angles. Okay, vertical angles. What do we know about vertical angles?
They're equal.
Equal. Vertical angles are equal.
Always.
Always equal. Okay, what do I mean by vertical angles? They're made, yeah, they're across from each other. They're made by intersecting lines. So this, when I intersect the lines, this angle is going to equal this angle. And that's why we get these little congruent marks there. Okay. Let's do number 14.
14.
I know that this angle is 40 degrees. So SQT has to be 40 degrees. You know how easy that is? You guys remember supplementary that you did on the test yesterday? These equal 180, right? Yes, it's a linear pair. So I'm going to take 180 minus 112. Gives me 78. No, 68. I was right. 68.
What?
Number 17. If this angle is 100 degrees,
That one has RQ.
yeah, RQT has to be 100 degrees. This angle has to be 100 degrees. So my equation is 4x. No, it has to equal 100 degrees. Divide both sides by 4, 25. Okay, angle RQT equals, we already said it's 100 degrees. And SQT, so this angle here, SQT,
Oh, it's 80.
80 degrees.
100 right there, and there's a straight line, and the rest of them have to be 80.
Yeah, we're looking at supplementary angles. Yeah, this one's 100. And then this one has to be make a line or 180 degrees. Let's do another one of those. 219. Okay, I know that these two angles are vertical angles. So what do I know about their measurements? Equal. Okay, now for x. Subtract 5x. Subtract 5x. So I get 1x minus 3 equals 18. Add 3. 21. Okay, the measure of angle YXU. YXU is 5x plus 18. Our x is 21 plus 18. So 5 times 21 is 105 plus 18 is 123. Let's see, WX, so this one's 123. YXU. Yeah, because they're vertical angles. If this is 123, that's 123.
Yeah, I know, you didn't sure about that.
Yeah, because this angle actually refers to this one. All right, so what's VXU?
Yes.
It's going to be 180 minus 123, which is 50. Which means this one's 57. Okay, so let's fill these in. WXV is 123. That's that problem. And VXU is 57. Okay, your practice work. Okay, so your practice work or your homework, if you don't finish them in class, I have to write your pass, hang on. Practice work is going to be the rest of the problems. And on the back is a little review of perimeter. Remember the perimeter, add up all the sides. And the triangle, the interior angles of a triangle, or the angles of a triangle, equal what? Add up all the angles, they equal 180. Nope, this is review. This is the new stuff. Angle bisector, line segments. This is a right angle. These add up to what?
90.
Good.
Complementary.